Hey everybody, today we're going to talk about graphs of equations. Okay, so first, the coordinate plane is created by placing two number lines perpendicular to each other. The horizontal axis is called the x-axis, the vertical axis is called the y-axis. So we've got a nice little picture right here. Okay, here's our x-axis horizontal, the y-axis vertical. Okay, the point of intersection of the two axes is called the origin. So my origin would be right there. Make sure you spell that right too. O-R-G or O-R-I-G-I-N, origin. Okay. The axes divide the coordinate plane into four regions called quadrants. So here's quadrant 1, quadrant 2, quadrant 3, quadrant 4. They go counterclockwise around the graph. Okay. Now, an ordered pair is a set of numbers that gives a horizontal coordinate, which is the x-coordinate, and the vertical coordinate, which is the y-coordinate. So, for example, the point 2, -3 would be 2 to the right of the origin. So in this case, that would be 1, 2 right here, and then 3, it'd be down 3 because it's negative. So it'd be right there. Okay, it would be in quadrant 4. So, if you happen to land like right on this axis right here, you are not in any quadrant, by the way. Okay, so you would say, oh, you would be on the negative x-axis, here you'd be on the positive x-axis, here you'd be on the positive y-axis, here you'd be on the negative y-axis. Okay, all this I'm sure is review for you. We've done this before. Okay, so real quick review here. Sketch a graph, y equals -2x plus 7. This is, of course, in slope-intercept form. Remember, this is your y-intercept. And this right here is your slope. So you're going to start with your y-intercept. It would be at 7, so that's where it crosses the y-axis. So 1, 2, 3, 4, 5, 6, 7 is going to be right there. And my slope is going to be -2, which means I'm going to be going downhill to the right. I'm going to go down 2 and to the right 1. Down 2 and to the right 1. And I'm just going to keep doing that. Okay. Now, I only really need to have 2. I always like to have at least 3 points, though. Helps me draw a better line. Okay. And I'm just going to draw my line right there. When I'm done. There's my line. Okay. So that should be a review for you. Very easy to do. Okay, here we got a line. Also, it's not in slope-intercept form. You have actually two options here. You can put it in slope-intercept form by taking solving for y. So I would subtract 4x from both sides right here. Now, a lot of people, here's what they do. I just made a mistake because I lost this negative sign. That negative sign is stuck to that 5. It's got to stay right there. Okay. And then I could divide by -5. And I would get y equals, now a negative divided by a negative is a positive, so it's 4/5 x, and another negative divided by a negative is positive, plus 4. So I could graph that in slope-intercept form. Okay, so my y-intercept would be 4, 1, 2, 3, 4. And my slope would be 4/5, which it would rise 4. 1, 2, 3, 4, run 5. 1, 2, 3, 4, 5. Right there. And I could draw my line just like that. Okay, so that'd be one way to do it. Now, what I would prefer to do in this situation is I'm going to take my equation. Whoops, whoa, what am I going here? I'm going to take my equation 4x minus 5y equals -20. And I'm just going to find the intercept. So I'm going to make myself a quick little table like this. I'm going to plug a 0 in here and a 0 in here. Now, if I plug the 0 in for x, that essentially makes that go away and leaves me with this part right here. And I just solved that. -5y equals -20. Okay, so I would just, you could write that down if you want to. Usually I just do this in my head. Divided by -5, y equals 4. Okay, and then I would plug the 0 in for the y. That's going to make this go away right there, leave me with 4x equals negative 20. And I can solve that. And x is negative 5. And if I graph negative 5, 0, that's right there. And if I graph 0, 4, that's right there. And guess what? I get the exact same line again. Okay, so myself, I prefer to do this when I've got this. This is called standard form, ax plus by equals c. I prefer to do it that way most of the time, but you can do it either way. Okay, special lines. Don't forget there's two kinds of special lines here. You got vertical and horizontal lines. So in a coordinate plane, the graph x equals a is a vertical line. And in the coordinate plane, the graph of y equals b is a horizontal line. So if I have this equation, y equals 3. Now, this is actually in slope-intercept form because people don't really think about this much, but it's y equals 0 times x plus 3. So it's slope and y-intercept. So it's in slope-intercept form. Okay. So my y-intercept would be 3. 1, 2, 3. And my slope would be 0. I'm just going to get a horizontal line. Now, the other way to think about this is you can say, well, it tells me y is always 3. It doesn't matter what the x is. If the x is 0, y is 3. If the x is 1, y is 3. If the x is 10, y is 3. If the x is negative 4, y is 3. What does that form? That forms a horizontal line at 3. Okay? Now, this one over here, the vertical line, x equals negative 4. This is not in slope-intercept form. This one was. This one isn't. You can't write this as y equals anything because there's no y in this. Okay? And the other thing is this does not have a slope. Okay? This one has a slope. The slope is 0. This one doesn't have a slope at all. Okay? This is a vertical line. So you got to kind of think of this like I did the other one. X is always negative 4. It doesn't matter what the y is. So if the y is 0, then the x is negative 4. If the y is 5, x is negative 4. If the y is negative 2, x is 4. If the y is negative 10, x is negative 4. And that just forms a vertical line just like that. Okay, so x equals a number, that's a vertical line. Y equals a number, that's a horizontal line. Okay, for 1980 through 1990, the per capita consumption, P, in pounds of canned white potatoes in the United States is shown in the table. Write a model that approximates the number of pounds of canned white potatoes eaten each year by an American. So if you look here, year 0, that'd be 1980, 1.2 pounds. In year 1, that'd be 1981, 1.1 pounds. Year 1982, 1.2, 1983, 1.2, so on. So they've graphed all these lines here, or all these points. Okay, so you can kind of see that it's just kind of almost a horizontal line. It does kind of bounce up and down. Okay, but we're going to approximate that. We can just put a nice horizontal line right through the middle of that. Okay, where is that? Well, that's going to be y equals 1.15. Right between 1.1 and 1.2. And although it doesn't hit exactly, it gives a very close approximation of how many pounds of canned white potatoes get eaten per person in America each year. Okay, so there's my equation. Okay, and that's it. Got a nice little assignment for you here. Have fun with that. I'll see you guys later.